All right, guys. So, welcome to this last part of the training. We finish examining the business case of IPv6. We want to talk about the best practices for planning the IPv6 transition. So, in planning IPv6 transition, we all know that now you are ready to go IPv6, and then your plan is either to go the dual stack, which is the ultimate solution. It's not even a choice. Your first option, as much as possible, is to go dual stack where you already have IPv4 and your network can support IPv6, or you go IPv6 only if you think it's necessary for you for now, right? Then, of course, the other transition mechanisms like translation and then tunneling. But how do you plan for this? It's very important. As we began with the business case part where we talked about the need to understand to get a business relevance, where we already mentioned three important things over there, such as the global internet, everybody is doing it. We talk about the costs being lowered if you do it right now. We talked about applications will be the driving force. We talked about to prevent the time pressure. Don't wait till pressure gets to you. It's also important that when you begin to plan for IPv6, the first thing you want to do is you want to segregate your network. Every network can be separated into a core network or a backbone. You can also get your DMZ or your internet connection phase, which you call the ISP. You can have your data center, which is also there. You can have your access connection, your access services where you connect with your various clients. So the first you want to do is you want to separate your network into these domains, okay? Clearly segment them into these domains, and we are going to treat the transition to IPv6 per domain. So how do we approach that? To approach that, we suggest three types of ways. After you segregated them into your various domains, the first one will have to do the transition from the core towards the edge, which is very optimal because we expect that your core network would have matured in IPv6, especially your ISPs would have already been deployed in IPv6 because they are the ones to even give you the prefix in the first place. So if you start from the core, not only do you get the advantage of working with low risk, but you also get the opportunity to leverage on the expertise of your ISPs who they would have already have deployed IPv6 in their core. So at times supposed to start from the core to the edge. Starting from the edge to the core should be something that you should avoid. You only want to do because your edge is your end nodes, your end connections to your clients. You call them customer facing devices. Um, those connections, you want those to be the one of the last things you want to do because those places they are not really matured unless you are hit with time pressure where you have to quickly deploy a service for the customer. Then you can start from the edge to the core. But as much as start from the core to the edge, and you could also look at isolated cases where we call them the IPv6 islands. So let's say that you are deploying a new, let's say, a data center, and your data center will be connecting to purely another IPv6 network somewhere. You can do an isolated case where you call an island of IPv6 connecting to each other, right? So once you have this, your plan, the approach is there. You've separated your network. You stated a business case. You've looked at the approach you're going. The first thing you got to do is you want to look at planning. And in planning, the first thing you want to do is you want to follow your existing change processes because every company has its own change management processes, which talks about what are the essential things that are required before you do a change, levels of approval, what is the quality of assurance test that needs to be done, and all those things. So you need to evaluate all that in respect of the IPv6. After you've evaluated you follow the existing change management processes in your company, you want to do a detailed health check on your current infrastructure, your current IPv4 infrastructure. We want to look at the health state. You don't want to build an IPv6 network on a network that is not healthy or that have issues. So you want to fix your issues. You want to do a detailed health check. There are automated tools. Almost every vendor has automated tools to prune the network. It's like a preventive maintenance tool. Huawei had it. I know Cisco has it. Juniper will have it, and then the other vendors will have those kind of tools. So you run the tools over your network in an approved maintenance window to get the current state of your network. If there are issues such as some interfaces are already failing, some routes are being denied, you have issues with your network, you are purely doing a network audit at this stage. Do a network audit on your IPv4 infrastructure before you deploy IPv6. After you've done that, and then you fix all those issues at IPv4, because we expect that IPv4, sorry, at IPv4, you're already an expert there. So after, the next thing you want to do is you want to form a governance board. So your governance board must necessarily include all your stakeholders. All your stakeholders are not just the network implementers and their consultants and experts, but anybody who will be participating, any discipline who will be checking their services after we've done the deployment. All those things must come onto the governance board, the CTO, the various department heads. If it's a mobile network, you want to involve your core network, your IN, your various, all those, your mobile, your radio access, all departments must necessarily come on board. Anybody who you as a transport owner, you provide them service, must necessarily come on board on your governance. The first you want to do is you want to do lots and lots of training with your governance board. Provide them enough training, hire consultants, provide them enough training on this. After you've provided them enough training in terms of what is IPv6, what are the advantages IPv6 is bringing over, what are the trade-offs and all those kind of stuff. Provide that kind of training to your governance team. Once you provide the training, you want to build your high level plan. So your high level plan should involve what kind of apps you think as soon as possible require IPv6. You want to leverage on what is the IP block you have been given and all that. So you have to define your IPv6 requirements based on the network assessments you have done, which nodes must get IPv6 and which nodes must not get. Then you also want to, before anything, most important, you want to also evaluate with your vendors. So if you have Cisco, if you have Juniper, you have Nokia device on your network, you want to contact your vendors to know what features are in there that will support the IPv6 deployment. For example, even though some vendors could tell you that the device supports IPv6, it could come with a license where you have to buy the license to deploy IPv6 fully end to end. So you want to leverage on that to have discussions with your vendors to foresee if the equipments are ready for IPv6. So you want to evaluate your vendors, you want to evaluate your products, and your service providers. Want to engage your service providers to get the necessary IPv6 and how they are going to route the IPv6 towards the internet, your IPv6 towards the internet for you. These are engagements you want to do. Once you've done that, the next thing is that you have a high level overview of what nodes we have in IPv6. You need a pilot study. A pilot study is where you could leverage on another company or another team who have already deployed the IPv6 end to end. You want to get into contact with such people. You want to know about the lessons learned so that you do not repeat the same kind of mistakes in your environment. You also want to build a lab environment and then start playing around with the IPv6. It helps a lot. How to configure the various interfaces, put the IP address on it, how they do routing and all that. After you've been able to build your pilot study, peer reviews as well in terms of so very important. You want to get experts, consultant to review your solution for you. With all this, you then refine your high level because it will influence how you should go about your high level. So after you refine your high level, you now want to go into your low level design. In your low level design, you'll be mostly be talking about addressing how you're going to do your address schemes, what subnet chunks you'll be providing to each of your departments, and then all that. After you've dealt with that kind of addressing scheme, and in addressing, we say that do not bring in the mindset of IPv4. You really want to, because it's hierarchical in nature when it comes to IPv6. So you really want to be concerned about the addressing schemes over there. You plan your addresses, then you also have to make choice of your routing protocols that support IPv6. For example, if your routing protocol you are deploying is OSPF and it's OSPF version 2, that is purely for IPv4. You need to add on top OSPF version 3 to support routing in IPv6. If you're already deploying ISIS, which most ISPs do deploy at a large scale, then you are good to go, because ISIS, I think the only thing you need to do is in the ISIS, you need to run a simple command that imports the IPv6 topology into the ISIS map. That is the only thing you need to do, and ISIS will be ready to support it. BGP is good to go. BGP version 4 plus is the same thing that we are doing. All you need is to introduce your VRFs, new VRFs to carry your IPv6 traffic, and then you'll be fine end to end. Okay. So you've planned, you looked at your routing protocols, you want to look at your security concerns. So you want to also look at in terms of security. Security is already built in there, but you also need to look at certain things like the NDP discovery protocol, which can be eavesdrop. So you want to strengthen, you want to look out for your AD authentication into the networks and all that. Make sure that they are actually supporting IPv6. You have also worked on your firewall to allow the necessary IPv6 pools, and then those that needs to be denied, you worked on it. Then you also worked on your DNS. So your DNS will now have to be able to support quad requests, IPv6 requests, and that. So you also want to do a plan for that, not necessarily but do a plan for that. Then you can now have your detailed low-level design out, which has all the infrastructure for IPv6. Then you are ready to do deployment. So generally, that'll be that. Touch on security, touch on how you're going to manage. That is good. Address management is also a very key thing. IPAM will help you to manage your address allocation IPv6. And then general network management systems, NMS should be able to support the IPv6. You also really want to consider avoiding NAT as much as possible in your solutions. So generally, what it's all about here is have your business goal met. Start from, so there's a document here. Let me just quickly run through that document, and then I think we can be good to go. Still by Sylvia. So planning for IPv6. So it talks about first the business relevance. That's what I talked about. So in the business, we already talked about how important it is. You want to segregate your network into the core, the user plane, the data center, and the DMZ. All networks can generally be divided into this area. I want to treat each of them separately, and you want to follow an approach. Your approach you want to do from core network to the edge, because I say that so the IPv6 stacks are more matured, and you can usually deploy with least upgrade efforts when you start from your core towards your edge, right? The complexity of IPv6 integration increases when you move towards the edge, and the implementation are either not available at the edge or are in early stage where you have to solve a lot of bugs and all those kinds of, and application compatibility issues. So vendor support may also be an issue at the edge. So while you work on the core, you build all your experience, and by the time you get to the edge, hopefully the market is matured enough for the edge side of it. So that is the goal, why you should always start from your core. And while you work on deployment in the core, your critical user or customer traffic still runs on the IPv4, yes, because we've not cut over services yet. It's still running on IPv4 infrastructure. So that's dual stack. So you can deploy IPv6 with no risks, zero risks, and then there's no pressure on you. So always start from the core. And then you can implement management and security. You can test as much as you want, and then be ready when you are now ready to do service cutover or to use IPv6. Helps you to train your people, get experience in managing new infrastructure, and build your support team. Edge to a core is something that we will not recommend. You can only do that, let's say, in cases where you are running out of IPv4 addresses and you can't cover the entire demand of traffic growth. It's risky. The project is risky. It's significantly when you choose this approach, and you want to avoid this situation as much as possible. And this will cause project delays because you can hit bottleneck issues which you don't have enough time to solve. You need to bring, and it's very expensive. And most importantly, your engineers are not ready for when you start from the edge to the core. Because edge to the core brings in services, unlike the core to the edge where you deploy it in the core and then you have enough time to now be ready to cut over services. Island scenarios are peculiar approach you can use when you want to deploy IPVs in a specific application. I talked about it, or parts of the network first, right? And for example, tunneling can be used to connect these scenarios. Okay, so once you've known the approach, the first thing we just talked about planning, and in planning you want to follow your existing change management process because they will guide you. The current processes may or may have to be adjusted to account for IPv4. That is true. But in your change management, you have quality assurance, and then you know what you expect of every product. You may want to do some modification. So IPv6 communication to ensure that, and then also this is very key when it comes to change management process. You need to communicate that once you begin this process, it necessarily means that all new changes that come to your network must begin after you deploy it. All new must have IPv6 ready, and not that you deploy IPv4 and IPv6 at the same time, because the time for you to will be increasing your workload on IPv4 at the same time IPv6. So as much as where possible, you want to leverage more on IPv6 than IPv4. So future changes, if possible, support IPv6. Go for it than to deploy IPv4 only to later on to solve the service into IPv6, right? You want to perform network health check to look at the state of the network, ensure so that you can get all the opportunities that you require to fix them. You don't want to put IPv6 on a network that has issues, right? And here, in network health check is not just looking at your LLD or your HLD documents that you are giving to, but actually getting to using a tool. Most times you use a tool. I've done audits with tools where in the network you look at it gives you the state of the network, where are the bottlenecks, what are the issues, capacity wise, quality of service wise, interface failures, routing failures, certain filterings in routes not really working. You can get all those kind of things from there. Then you now create, after you've done that, create a governance board where in the governance you'll be educating your all your people about IPv6, very, very important. And then you also want to hire consultants which have already done this project before. Okay, so your degree of consultants can vary. It can vary from one with low level. We normally want to call them second level support, third level support, tag, and then R&D. So if you have the enough resources to buy up to that level to support you, that is good on the job. Okay, then you now come with your high level, which you call the HLD. So HLD will look at which are the areas you want to get IPv6 deployed, what are the nodes, what interface will be required. So you plan your HLD mostly, you draw at a high level what and what is going to connect to each other. So you build that HLD. Then after that, you want to do a pilot study with your HLD, right? And when you are doing, you want to mind where your apps are located. So you do a pilot study. What is a pilot study? So the next is your IPv6 requirements, and then do some network assessment has already been done, but build a pilot study to be able to look at that. Prior to that, you can also evaluate, very important, evaluate your vendors and then ensure that your vendors actually support the various features that are bringing in. Okay, then you can build, you also build the labs to test and then make sure that everybody is familiar with the processes that you are going through. So you have your low level design. You can now refine your high level. You've tested the scenario that you want to deploy on the network in a lab environment or based on a pilot stage. You've learned all your lessons. You can now define your low level deployment plan as well. Then your low level, you want to make choices about your routing protocol uh, that you're going to use. You want to, as much as possible, make decisions about your addressing block that you have been received, your IGP, OSP. I've already talked about this. Their support for IPv6. You want to look at, yes, your addressing plan, what subnets you have been given and what subnets you are issuing out. And then more important here, I'll talk about key about when it comes to address, simplify the configuration, processing of set lists and firewalls. Okay, keep them simple and clear. Make addresses easier to recognize by integrating locations and cells. So each location, maybe the banking location, maybe you give it 9001, operations 9002. So you have that order. We've already been doing this kind of thing. So just that give it enough, and then um you also need to understand the difference that here the concept of borrowing variable length subnetting is not in IPv6, so you don't bring that idea and concept over there. Generally, this is that. So, and then also you need to think about security. You need to think about your uh, DMZ, and then your NAT. Security concerns must also be there. There are concerns about if IPv6 perimeter firewalls must ensure that they are ready to support. Attackers can use extension headers. So what do you have to do? You want to protect all those things. Slack in its own has issues. So you want to, as much as possible, implement necessary security procedures, making sure everybody is participating in a discussion, applying what has worked well, and then reviewing and all that. AD services are important. Your DNS should now be able to support quad reports for IPv6 as well. So that is that for this. I don't think there's any other thing. So in essence, you want to plan for IPv6, you want to state a business case, you want to segregate your network, you want to use the approach of call to edge as much as possible. You want to plan your network, have a governance board, perform your health check ahead of time, follow your existing change management processes in your government board, define your IPv6 requirements, and then evaluate your vendors to support you. Build pilot cases, build your high level, evaluate your low level, make choices of your routing protocols, and then plan your IP addresses and then be able to go. So this is involved plan. The next you look out for is to discuss the various transition mechanisms. Okay. All right. Thank you.